Okay, let's give you guys some more practice. So if you were to sum up this sequence, if you were to sum up this sequence, will it come to a finite number or will it just get bigger and bigger and bigger and bigger? Meaning, is this series going to converge or will it diverge? So press pause and have a go. Okay, so to do this, we've seen this theorem in the past, or we are going to make use of number one. So start out with our series. So as n gets bigger and bigger and bigger, you've got, if you look at the denominator, when n gets very very big, this one here is negligible. So you can think of this whole thing here. This whole thing here is very similar to this as n gets very very big, because here the denominator, you're adding an amount that's next to nothing. So you can pretty much ignore this. It will act like this. So we know nothing about this series, but then we are going to make use of this series. Remember, this series, we know it's a geometric series. We know this is going to converge, and we've done this many times because you can visualize it like this. So we've seen this many times. By now, when you look at this, you should be able to recognize that this is going to converge. Well, we know nothing about this, but then we are going to compare it with this, and we know that this is going to converge. So hang on. So we are going to let this be an, and then we are going to let this be bn. So remember, the theorem says that if the limit of an over bn comes to a number greater than 0, then if this thing diverged, then this thing will also diverge. If this thing converged, then this series will also converge. That's what the theorem is saying. So now we need to check. We need to check this now. So this is our an. This is our an, and this is our bn. This is our bn. So now let's check this. So the limit of an, so this is our an over bn. Well, let's see what the limit of this is, and we need to check that. Well, we need to check that the limit is going to be greater than 0. Then we can apply this bit here. So if this thing converges, then this will also converge. If this diverges, then this will diverge. So we need to check this bit now. So an over bn, an over bn. So tidy this up. So this thing times the reciprocal of this, which is this. So now it's top times top, bottom times bottom. That will then give you this. Divide top and bottom by 2 to the power of n, 2 to the power of n, 2 to the power of n. That will then give you this. This is going to be 1, 1. As n gets bigger and bigger and bigger, this is going to become very very large, meaning the whole thing here will head towards 0. So this whole thing here will become 1. So looking back at the theorem, we know that if you get an divided by bn divided by bn, this whole thing here comes to the number 1. We know the limit will be 1. Well, 1 is bigger than 0. Now we can apply this theorem where it says that if bn diverge, then this must also diverge. If this series converge, then this series must also converge. Well, bn, we know in the past that this thing here is going to converge. Well, if this thing here converge, if this series converge, then this series, which we know nothing about. So remember, we know nothing about this series, but we do know something about this series. We know that this series will converge. Now this series, we don't know anything about, but then because this thing here converged, and therefore this series, the one that we know nothing about, will also converge. So this series will converge.